Okay, so we're moving to the next speaker now, Engineer Bola. Yes, sir.
Thank you very much. First and foremost, I want to appreciate the head of this cluster for this opportunity given to me again to make a second comeback, not second coming like our Lord Jesus Christ. This second comeback of Engineer Bola for the continuation of what we started last month. I greatly appreciate this privilege. Like I will discuss with the MC, what we are doing this evening is going to be more practical than just presentation, so that we can take good advantage of our HPC utilization. We have high performance computing in Covenant University, and we want researchers and our postgraduate students to make effective use of this infrastructure. And that is why we are organizing this little training. And we trust God that it's going to be very impactful. It's a short time. 1 hour is not enough, because I don't know the background of every one of you. And again, I'm just the main presenter for today. 2 other persons will also join me, maybe 10 minutes to also make some aspect of presentation. I have John Wenjun will be joining me. And also we have a cloud consultant in Covenant University, the person of Mr. Tolu. He will also be joining us in this presentation. Once again, Prof, I appreciate this opportunity. Last month, I make a presentation about the high performance computing in Covenant University. And this is just a schematic of what we have. Just briefly, let me just describe to you as a researcher, as a student, as a user. You can see yourself there connecting through the internet. This infrastructure, we call it FEDGEN HPC, is actually located in Covenant University. The CApIC-ACE has a data center where this infrastructure is installed and being managed. We have the compute node, we have the storage, and we also have the GPU. Before you can log into this infrastructure, we have what is called the login node. The login node is the first thing a user will get connected to. I will just be brief because we are going to the main practical section very soon. This is just a brief introduction. This is more or less like the login node. For you to get into the login node, there's a URL, and you do that through the SSH. I mean, you do that through the terminal, through the command line. And the URL is allots.hpc.fedgen.net. We'll all be doing this this evening. And please, I want every one of you to get set with your computer system. I know the other time, Uche took you a little bit of Linux command, if I'm correct. Uche, they are already familiar with a bit of, they have PuTTY on their system. So please, just get set with PuTTY. We also have other tools that can be make use of, which I will introduce you to all of that. So for you to connect, we have what is called the login node, and that is where you connect from. And the URL to the login node, which every one of you should know, is allo.hpc.fedgen.net. And we get connected. You know, normally SSH by default it uses port 22. But in our own case, we have changed the port number to 2204. So be aware of that. You have to specify the port number when you are logging into our high performance computing infrastructure. Like I said, we have the login node, we have the compute node. This is just a description of the compute node. If you want to do any analysis that requires CPU, you know, there are different type of analysis. And that is why when you'll be making your request very soon regarding what you want to use in the high performance computing. I mean, among our infrastructure, whether it's HP, whether it's the compute node or the GPU node you want to make use of, all this will be specified at your request. And we also have the GPU node. The GPU node, most especially for building our AI models, for doing some form of analytic that requires GPU. So when you know you require more of GPU than GPU in your request, you make a request for GPU. We also have the storage node. Like, some of you will be making analysis and you will need to store your data. Even as you are making your request, we attach your request to a certain number of storage so that you can store your data and then you can thereafter retrieve it from there to your local computer system. So the high performance computing is also made up of storage node. So straight to the business of the day, getting started with our HPC. Like I said, we have 3 persons that will be making short presentation. Okay, I didn't mention this. On our GPU, we have what you call the coding hub. It also have a graphical user interface through which you can log in to do your analysis, to build your model, and to do quite a number of things, which we'll also be presenting today and show you how to go about it. Getting started, before you go forward to use our GPU, please, we are starting right away. Like I said, I don't want to make it like a presentation. It's not a talk of a thing alone. I want us to right away be on our system. So I want to ask, are we on our system right now? Okay. So if you want to make use of Covenant University HPC, there's a request you are going to make. Sorry, the URL there, we have not done the CNAME to this. So I will share the URL on the link. So what I'm trying to say is that all of you right away, you are going to make requests for a space. Obtain what you want to do now is that you want to obtain your account. And for you to obtain your account, you have to make an official request. Making this request, we have different type of user. You as a researcher, we have people that also make, the people in the industry also make requests. So we have different set of persons. So you will indicate in the form where you are the kind of person you are. If you're a researcher, if you are within Covenant University, if you are a collaborators. So I want to get this URL sent to you now. Have you sent it? Okay, it's in the chat. So please, can you get this? And if you're on please, can you all connect to it and pick up the URL for now? We are trying to work on the URL so that it can just be a simple word now. So that is where you make your request from. Please, if you are there, can I see people online? Just look through the chat and you click on please, you can unmute, or if you have any question to ask, please, you can just ask your question. If you are there, let me know. So this is what you are supposed to see. You make a request. I'm very sure you are there. Are you there? We are doing some practical, and before you can have a login account, you need to make a request. So, and this is the first page you have to go to. For anyone that wants to use our HPC, you have to go to the FEDGEN Datacenter, which is an online platform where you make requests for your account. Why not just join the Zoom and quickly just copy it and log out from the Zoom? The online participant, please, are you there? Online participants, if you are there, please, can you signify by raising up your hand so that we can move forward? We have very, very limited time. And if you want to make it practical, that means you all have to have an account. So please, let's be fast about it. Online participants and the people physically here, I want you to all make requests for an account, and then you will get a response for this. You create an account.
Okay. Engineer Bola, we are having yes from some online participants.
Yes.
We have yes from Mr. Usman.
Yes. We have
yes from Engineer Kenny Alonde. Kenny is our industry partner. Good to have you in this meeting. Then we have Anthony Michael Idedia saying yes. Okay.
much.
Emmanuel Amadi saying yes. So quite a number.
So we are happy we have that. So you will get a response regarding that on the creation of your hack. Mr. Tolu, are you there?
Okay. Emmanuel Amadi is asking for the link again, but I think
we have resent it.
It's been sent. Yeah, it's been sent.
I'm here.
Okay, thank you.
I think so you might want to start from the user account request. You are on resource request. If you go back to the epicenter.
Yes, user accounts. That's what's.
You're on resource request. So you might want to point that to the account request first. That's the kickoff point.
So you have to create an account. So you should be on this page after creating an account. So you click on this FEDGEN HPC account request. That's what we do first. How many of you are, if you are done with it, can I see you by raising up your hand? Okay, you are just signing in. Let's be fast about it. Okay, you are done. Okay. Are you seeing the people that are making requests for accounts? I will just take 2 or 3 persons from the participants.
And but I think those in the lab can also form a group, maybe a cluster.
Okay.
That exactly. Then it will be easy for the persons assisting you to attend to such cluster. And have like maybe persons clustering together. That might be, yes. Then those online, you can give us feedback through the chat box if you have made any progress. I'm seeing Anthony Michael Ideda thumbing up. I wonder, okay. There's one EA that is saying, I can't see the link. I think John can resend the link so that we have everybody picking the link up.
So maybe,
okay. Engineer Bola, from my own end, just to give you feedback.
Okay.
Yes, it brought out a window for, of course, I've signed to the platform before. I just wanted to follow what you're doing to sign up. And it gave me a feedback that check your email to finish sign up. We sent a private sign up link to the email I indicated. But going to the email, I didn't get anything. So I just wanted to see if
refresh.
yes, I'm refreshing now.
I have someone who has gotten here.
Okay, good.
Okay, Comfort who has gotten. Just
okay. I think no problem. I think to everyone. Okay, so Tokwe has resent so EA can pick that up. Okay, I think the EA is Emmanuel Amadi. Okay, you can pick it up now. It's been sent to Tokwe has resent the URL. Okay. Yeah, refreshing. Okay, thank you, Nebola.
we are good to go.
No, you can continue since others are making their following.
Okay. So the next thing now is for us to we'll pick it up now and create an account for you.
Okay, so what is next, Engineer Bola? We have feedback from online.
Okay.
I've received notification via my email. What next?
Okay.
That's Dr. Okun
make requests
from the university.
Request, and then we create the account. So we might not be able to create account for everybody right away, because normally when you make requests, we analyze your requests. It doesn't just create them automatically. So maybe I'll just want to pick like 5 persons. I'm sorry for that. We might just pick like 5 persons, maybe 2 online, 3 physical. I think that's what we're going to do just to make it faster. So can I one from online we ask?
There's Dr. Ejidokun, there's Anthony Michael Idedia. Okay. So for online participants, if you have received the notification, you can also indicate through the chat box. That will help to create the account for you to access the HPC. Okay. Then, okay, we have Anthony Michael Idedia has also received a notification. And Debola, kindly attend to Dr. Ejido Kunde and Anthony Michael Idedia. So we have those two from online. I guess Engineer Kenny has also received the notification. Kindly confirm so that we make you the third person.
Yes.
Okay.
Wow.
Thank you. And Debola. So we have three persons from online now, Dr. Ejido Kun and Mr. Anthony Michael Idedia and Engineer Kendi Alao. Okay, there's one admin saying that I've signed in. Okay, that means an account has been created for him.
For now, if you have PuTTY, you can also make use of PuTTY. And then for people using Mac OS, which that's what me I'm using, you can use items. It's better than the normal terminal that comes with Mac OS. It has some other form of tools that makes it more convenient and more friendly for you to be able to communicate with your servers. So I recommend now we go through our PuTTY, and then if you log in through your PuTTY, so let me demonstrate that now. I'm currently using a window machine, and on this window machine, I have PuTTY installed. So I'll be sharing my screen now. I will stop sharing now, then I will do some form of demonstration so that we can all see what I'm talking about. Can we see my screen?
Yes.
Yes.
Okay.
Can make it bigger, that would be nice. You can make it bigger.
Okay. Because I have to stop sharing first.
Okay. My username is Bola Dele. And my password is I want to believe that everyone that has the login can get to this place. If I've created a username and password for you, can we all get here? No.
Okay, I think
Yes. Yes.
yeah.
I could get there.
There's a
Let me just be
confirmation.
sure.
There's
Let
a
me just be
confirmation.
sure that yes, from the lab here, I've not gotten anyone.
Basically, I want to talk about the resources. Once you log into the cluster, the first thing you probably want to do is to type this command, which is sinfo. And it's going to give you all of the available resources that you have. So if you look at this table, it shows partition, avail, time limit, nodes, state, and node list. So for example, the FEDGEN HP cluster is running a resource manager that controls everything within the cluster. So and that is Slum, the Slum software. Slum is an high performance resource manager. It controls a whole lot of things within this particular cluster. So, and usually all of his commands to a large extent start with an S. So when you type sinfo, you want to see the details about all of the resources that are available, be it GPU or be it CPU. So, and you can see here that we have three segmentations or three segments. We have resources in for BAO, we have full, and we have resources for debugging, and they are currently available. And you can see that if you look at the partition for BAO, for example, we realize that you have two compute nodes dedicated to that. The compute nodes that we have within this HP cluster, they are called Giga. So when you see Giga 001, that is a name for a node. Giga 002, that's the name for a node. Giga 003, that's the name for a node. If you need to know more about the node, any of the node, or to know about the nodes are available, you can type this command. Let's control show nodes. When you type this command, it gives you details about the the node configuration. For example, if you look at this node 2, we see that this is Giga 002. The architecture is x64. The cost per socket is 20. The effective CPU number of cores is 80. And that's why you have this. You can see the actual node address here. And you can see the version of the slum that it is running. And you can see the version of the operating system that is also running here. And here you can see the memory size. So this is a 502 gig server. And also, I'm going to stop there for now, talking about the resources available on the node. They're actually the same for all of the 3 nodes that you have. Now, for you to begin to do anything with on the cluster, you begin by creating what we call jobs. Now we'll try to take my cue from the documentation website, which is FEDGEN HPC docs, to show us how you go by. Okay, so now if you are in the documentation, this document website actually contains a lot of details about the jobs. For example, okay, let me just do through this quickly. Okay, I don't know, the internet is not moving as fast, but primarily on the cluster, there are 2 ways you can execute a job. There are 2 types of job: the batch job and the interactive job. The interactive job is you issue a command. You issue a command, and then interactively you can follow the steps that the command gives you. But with a batch job is a file that you put in all of the commands or parameters for your resource request, and then you can then run your application or your program. Now, I want to take a cue from here. Now, the resource manager is able to manage the nodes, the number of cores on a system, the number of threads that you have on your processor core, the memory allocation. You can manage GPU allocation. You can also manage license. So, for example, if you want to run something from MATLAB, there's ways it's able to distribute license. So, when talk about resource management, those are the resources that your resource manager deals with. And in this case, we're using Slum for that. Another important thing to note is the Slum Workload Manager parameters. I want us to see the different parameters that I work with. So that will give us a guide on what to do. So for example, we have a table here that talks about if you are to request a parameter, the resources, you want to specify the time for that. You want to specify the nodes, the number of nodes that you need. Do you need 3 nodes? Do you need 10 nodes? What's the size of memory that you want to make use of? Then the number of tasks. We need to understand the fact that because an HPC cluster is a shared resource. So if somebody is executing a program that needs just 100 MB and the fellow is using the entire 512 gig, that is not effective usage. And it will not allow the Slum system to work very well. That is why it is important that you understand the resource requirement for the job or the application you want to execute. And these parameters you use in requesting resources from the resource manager. Another thing also is that you could have some other control parameters for your job, and then you could also maybe have parameters to request that, okay, once this job is completed, send me an email. As this job is beginning, send an email, because within Slum is a queue. If 10 people were to use the cluster, it's going to give priority based on several parameters. So there's a queue. So it's that queue that it uses in managing or distributing resources appropriately or adequately. Now I'm going to go back to a researcher now. You want to execute an application, you want to run an application on the cluster. So, and I'll go to the job script examples. Please, if you have questions or you are not really connecting, I can stop briefly so I know where to revisit quickly before we go further.
Online participants, please let's know if you're following. You can just type following on the chat box. For physical participants, please, are you lost? So that we can just ask Mr. Tolu to rewind, please. Are we together, online participants? Okay, someone said following. Thank you.
Yeah,
Okay,
thank
good.
you very much. Okay, please, the physical participant, just concentrate. Like I said, we might not be able to get you understand everything today, but one thing you need to know first is, do you know how to, Mr. Tolu just showed us something now. Do you know how to get to know about the information that is available, the sinfo command? Immediately you log into the cluster. Because you also need to know about the resources you want to use before even making some requests. So now this is what we are saying. When you log in, this is what you will see. Please, can you type the sinfo again? Please, let's look very well. Even though we are just going to gain few things, let's be able to go home with an important information. Quite a number of you have the login details now. You can go around to play around with it. Also, going back to the the documentation that you just showed us online now, doc. I will give you the URL. So please, can you type the info again? Because quite a number of them were not listening when you were here. Now, this is showing our compute infrastructure. Yes, it's not that big, but we have something and we are starting from here. So if you look at it, when you request for information, okay, we have 3 compute nodes here. It's not showing the GPU, but the 3 compute nodes, depending on what you request for, you can request for 2 nodes. You can request for a node depending on your the computational resources you request for. At some point, we can decide to give you just 1 compute node. And that is what you are seeing at number 1, called the debug infinite 1 node. And then at some point, depending on what you want to do, we can decide to give you the bow, which will give you 2 compute nodes clustered together for your computational assignment or analysis. And then at some point, we can decide to give you the full, which is number 3. You can see it talks about figure to 001 to 003. I don't know. Did we get that? Did we get that? Please, I want you to respond. Online participants, I hope you are following us. Yes.
Yes, sir.
Our computational resources will soon increase beyond this, but we are just showing you of these 3 compute nodes that we have here. And when you make requests, these are things that you can have. You can have 1 node, you can have 2 nodes, and you can have 3 nodes clustered together. So next, Mr. Tolu.
Debola, can you also, okay, Tolu, please also show the available storage, because, you know, it's not just compute that we have storage too. Those doing AI task and bioinformatics, those kind of jobs are storage intensive, so they will also want to have an idea. Okay.
So let's do it this way. If you check very well, there is let me minimize this. Once you log into a node, okay, talking from the point of the user now, once you log into a node, once you log in, you are logging in into your own home directory. You're logging into your own home directory. From that home directory, you can run your application. There are 2 other directories that are important, which is the FEDGEN, the FEDGEN. You see, when you are doing HPC, you want to run your application or you want to run whatever, a simulation. Now, you can afford to run some applications from your home directory, but in the event that you you want to deal with a lot of files. So you use the FEDGEN Scratch for that purpose. But if you belong to a group, you get a FEDGEN research group. That is where group storage is. So I would have, okay, maybe I think let's do it this way so we can easily, because we've done it. So I want to take the user journey on the application. They will now come to the storage part. I've noted that.
No,
So
can you
once you log in, I want to go back to the storage. I want to take the user journey. We've done the onboarding, then we've attempted the login. So once you log in, you are in your home directory. And from your home directory, you can do whatever you want. Your home directory is private to you as a researcher. But in addition to directory, you have access to FEDGEN Scratch directory, which is all large files. So when you are, for HPC, you have the input files and files, because we will not necessarily allow you to use all of the storage in the cluster. So the storage is managed. We expect that you also use the storage responsibly. You move in data and how you take out data. So because over time, there'll be files might be taken off from the Scratch. So your input data, you have to put them, and then your output data where you're going to put them. So the directory is permanent for as long as possible. It might not be much, but it's permanent for as long as you are still log into the cluster. I think those is added. But we want to show how to run an application on this cluster.
Sure.
So we have test application in this directory. Though I think we'll create something a bit standard after now, so you can use it. Now, I said earlier that you have two ways you can execute a program or an application. Is to interactively, that means just command to run. For example, I could just type this command srun hostname. I could run that command, and you can see the result of that command there. Please, did you see this? Can we see this, please? I want to respond, so if I continue.
Okay, yes, from my end.
Yes. So I want you to look at something which is very important, because the flow of usually you don't run your application on the login node. But if you realize, if I type the command hostname here, you can see that the name of this computer is alot.hp.fedgen.net. But when I type this srun hostname, what it did was that, because the Slum took that instruction and went to execute the hostname command in the first or on the default compute node in the cluster, which is giga001. And that is why it gave me this hostname as hostname. I don't know if that is clear. So usually when a command is executed, execute a command, this command, it goes to the compute node or the GPU node to execute that command, depending on the one that is available, or depending on the one that is the default. This star that you have on this debug shows that that is the default node. That has been dedicated for that purpose. I'm going to run the srun command just for you to see. Forget about the the error it brought. So you can see again, srun. This is an iterative command, but the second command is to.
Are you typing anything, Mr. Tolu?
Yes,
Are you? Did you just type anything? Because
yes, typing.
Not changing. From my hand here, we are not seeing that. I think maybe it's a net.
It should be changing.
I think it's network.
Hello. What about the other participants? Are they able to see the changes on this?
Yeah, it's changing from this end.
Yeah, it's just
so. What
I think it's Enabler's network down there.
So what I've done is to open one of the batch job. This cluster is a test job for us to run tests and be sure that things are operational. So within that file, we can see that it starts with the shebang command, and once you want to create a Slum batch script or batch job, as it's called, you start with the shebang. All the parameters that you want to use to request resource will start with the pound symbol and then S batch. So you can specify job name. In this, you can specify the partition we want to use, meaning the segment of computers we want to use. Then we can even specify the we want to use with that partition. In this case, we've selected giga 002-003. Here we've requested a 1 gig memory. We've also specified the number of nodes here. Here, the task we want to run. We can discuss more about these nodes and tasks some other time because there are a lot of details behind that. And the number of speeds for tasks. And when you have pound symbol, it means comment. So if you want to comment a line, just add pound symbol. Then the last one is the time, how long to run for. In this case, it's 3 minutes, 30 seconds. So this is a structure of a Slum batch job or batch script. After you have all of this talks about the job what they call the job parameters. After you are putting your job parameter, the next thing is the command to execute your application. In this case, we have the first command, which is print working directory, which is the Linux command to show where you are within the file system, the date, and then we have a command srun hostname. Srun, meaning that I wanted to get me the host name of the nodes that are a very simple job script. Are we right now? I will run this, and then we can move to the next level. We close at this point.
Hello, Ebola, are you still there?
Lulu, we can hear you. But Prof, I don't know with your permission, because I can see that quite a number of people present here physically are struggling to understand what we're doing.
Okay.
Yes, though quite a number of them have understood it to a certain point. But what we are currently doing now, quite a number of persons are not getting it.
Okay.
So I don't know about the online participant, because they are not used to this.
Can I ask a question?
Yeah.
Okay.
That's a question.
Right.
One or two persons that are not clear, I want them to actually ask me questions, so I actually know where the pain point is, and I can easily address that. And
it's when you understand something that you'll be able to ask questions.
Okay. I think
not clear.
A hand is raised up online. Engineer allow raise his hand.
Okay.
Yes.
All right, sir. So thank you for this. You know, my comment is from my own perspective, I'm following quite all right, but the environment is new. So what I think is the ability to play around with the environment will help. So I know because we are constrained against time, you can't allow us to follow interactively. So I think that interactive element that's missing, I believe that's what's affecting people. So maybe if there's a follow-up session where everybody can participate.
Let's do that. Let's address that. Okay, I think that is clear.
That will be good. Yeah.
From the physical participants here, being that I'm here, I can see that they are not getting it the way they are getting it. Okay, you want to ask question? Okay. Oh yeah, make a comment. Thank you.
Good evening, sir. So I want to mention that we would appreciate if this can be made into a workshop for us bioinformaticians, because this is a tool, a very important tool that people use out there to work and to do analysis. We can have a workshop on, and so that we can get it in depth like we intend. Thank you, sir.
Okay, thank you. Do any other person have it? Okay. Yeah, so Prof.
Yeah, okay. The comments are noted. Engineer Kendi has made a comment, and I also heard the comment from the bioinformatics students, and they are really well noted. What is coming to me is having this kind of maybe training virtually is not going to be effective, especially given the challenges that we were having with internet. So we will go back and brainstorm on the best way to do a proper workshop on this. I think the right thing would be to have a proper workshop and make it known to the community, person that participated online today, and of course our students right there. It's not just the bioinformatics students, the student in computer science, the student in biochemistry, microbiology, and engineering. This is a vital tool. So Engineer Bola, we have to come up with a schedule on a proper, maybe we can make it a whole day workshop so that there will be a proper engagement of those that need to use this platform. That's number one. Meanwhile, this is the alternative to having access to the HPC platform. Okay, this batch processing and command line based submission of job. Currently, we have Jupyter Hub that quite a number of the research students have been using for their work. But I came to the understanding that the bioinformatics students, they are not really too okay with that Jupyter Hub. The Jupyter Hub is GUI, so it's extremely interactive. If you are doing an AI job, it's a photo for you. I was thinking there's going to be a demo of that today. That can easily be done online. So maybe we reserve the next session for the coding hub. But for this aspect of the training, it will be better we have a proper workshop. So that's my suggestion on that. And Debola.
Yes, thank you very much, Prof. I also, before now, I know that will be, I didn't preempt the network, but I know there will be difficulty in understanding this 1 hour. But what I want to recommend before we even go ahead to plan the workshop, for all that have the login now, you can go to the HPC doc, the full documentation on how to use the HPC. And then I'm also available. You can always reach me in my office at Access Bank for any question, even before the main workshop. Before, you can also ask questions, be able to have some kind of understanding, to be able to ask reasonable questions or questions that will enhance your understanding. So if everything is looking like a magic to you, there's no way you'll be able to ask questions, and that is what is happening today. So what I will recommend is that quite a number of you have the login now. You have the URL to the HPC doc online. Then there are other materials online that can aid your understanding of how to use it. So there's no excuse now. Before the main workshop, yes, we are going to organize another tutorial. It might even be 2 days hands-on and all that. Why we don't know yet, but I think Prof is going to look into it. But what I want to just encourage this evening is that you have the login details now, and then you have access to the documentation. That's the FEDGEN HPC doc. Start practicing. Go and read. Then by the time we organize any other form, you'll be able to ask the question, and then you have a better. Thank you very much.
Okay. Wow. It's been a very long day. And I think it's this thing is just like when you want to give people the best, you don't know the extent or you should go is until you bring it out, until you experiment it before you actually. So we've taken our feedback. Thank you so much. So next month, by God's grace, we just have maybe 30 minutes on how to show people how they can access our coding hub. That's not difficult at all. That one you'll be able to run your scripts and whatever you want. It is user friendly. I think it's on Jupyter. So that one, it's very easy. For these, I think it's going to be strictly workshop. So for online participants, if you want to be part of these in Kwara State, you can just fly down to water. It's not that far. Okay, so we are taking this to workshop. Yes, I think that is the best. We'll just go back to our normal mathematical model. Okay, all right. Thank you so much, Engineer Tolu. Thank you for joining us. We'll definitely have you during our workshop. So thank you so much, sir. You can stop sharing your screen now. So before, I don't know, Prof, the last remark you made, was that your closing remark, or we'll still have a closing remark before the closing prayer?
Yeah, I think we can just to appreciate everyone. Thank you, Professor Mulano. I was hearing at the background that you also wanted to log into the that was really exciting when I heard that you were asking for your own login details. So we'll carry you along. Maybe we also facilitate at the workshop. So beautiful word. And thanks to Engineer Bola and the team that worked within Engineer Tolu, Romy Louis, and Engineer John Wedging. We appreciate the effort, and to all the collaborators and our industry partners that joined us. We want to say a big thank you. And of course, next month is another time we'll be coming together to take us to another realm with respect to this monthly advanced research tutorials. And once again, thanks to all the students, and I pray God will continue to strengthen us, and all our whatever we have to do in terms of research, God's grace will be sufficient for us. God bless us all. Thank you. That's my closing remark.